Hi, my name is Aaron, and I'm from Valley Christian High School, and my project is an automatically sorting trash bin system. This is my third milestone where I did CAD work and 3D printed the enclosure for my electronics and the trash bins with the servos that move them. So the way this works is that there's an ultrasonic sensor and a camera attached to the electronics mount. So if you hold either this is cardboard, supposed to be recyclable, which I think is, yeah, it's this one. This one should open. And if I scan this one, which is trash plastic, this one should go into this one. So this one, like that. And then you can just, it gives you time to put it in. I'm not gonna do that because I can't get it back. And for this one, this is cardboard. So uh, yeah, this one should open. Yeah, so the way this works is that there's two sensors here, and the camera basically sends information to the Raspberry Pi, and the Raspberry Pi has a machine learning model with different kinds of trash categories stored onto it. And each of these categories is assigned like whether it's recyclable or not. For example, plastic is put as not recyclable, so it goes into the trash, while cardboard is listed as recyclable, so it goes into the recycling bin. So this camera, it sends 50 different images to process to the AI, to the machine learning algorithm, and each time it records like how sure the machine learning algorithm is that the item it's scanning is one of the categories. So for example, if I scan this, it might say like it thinks it's like 50% plastic and maybe like 50% like a can or something, because the AI is not completely sure of what it's seeing. So, but overall, since it scans it 50 times, it makes it less likely to have like random induced errors in the system of whether the trash bin opens or the recycling bin opens. And the way that the I need a 5-volt power source here that's separate for the Raspberry Pi to power this thing, because the ultrasonic sensor and the servos need more power and a voltage than the Raspberry Pi can provide. So what I did here was I picked the right voltage power source, and I used a voltage divider circuit so that the ultrasonic sensor could send a signal that the Raspberry Pi couldn't set, because the ultrasonic sensor, even though it receives the 5 volts from the power source, it still has to send an appropriate voltage to the Raspberry Pi to get the signal. And the camera doesn't need to do that because it's directly plugged into the Raspberry Pi through a ribbon cable that is ported through the lid. There's like a hole here and the wires from the circuit from the ultrasonic sensor and the servos and the power source, along with the ribbon cable for the camera, it's ported through a hole in this lid. And the servos are attached to the back over here on the lids. So the way it works is that there's a servo horn here, and the lid is screwed onto this, and this is what makes it move. And to ensure stability, there's an extra axle that isn't powered on the other side to make sure that it doesn't wobble from side to side when it opens and closes, or just like in general. And there's also a fan on the back of the electronics case to keep it cool. It's mounted sideways so that it can cool the maximum amount of area without like, because if it was horizontal, it would leave less room for all the wires and stuff to be ported through. So since it's horizontal, since it's diagonal like this leaves more top surface area to mount the stuff. And there's also wires ported out of this hole in the back for the servos, because they have to go out and maintain their length. I also had to solder some of the longer wires into shorter ones by cutting the wires and removing a large portion of them, so that because the full length of the jumper wires had a set length, so if I had to make each connection with a jumper wire, that wouldn't work because there wouldn't be enough space to put all of them inside the Raspberry Pi. And even if there was, that would leave a very high chance of the wires like accidentally disconnecting or something. And overall, and there's also ports on the side for the power source for the Raspberry Pi and an HDMI cable in case I can't SSH and I need to debug stuff directly accessing the Raspberry Pi and not over the internet. Uh, an interesting part of the way I designed this thing is for the power jack, since it has no screws or any attachment points to screw it on to the electronics case, I had to make a clamp that holds it down from the top of it, and it's screwed on with a single screw to keep it in place. And on the bottom, you can't really see it on the electronics mount, but there's like a little like ditch thing that keeps it in place. And when I push down on it, it stays in place. Inside this little area is where the breadboard is. It's like about the same size as a mini breadboard that's mounted inside, right on top of the Raspberry Pi's ports. And the way that I kind of did the layout for the electronics was I kind of just like, before I had the case, I was kind of like just arranging the parts and like testing to see which arrangements were possible with the length of wires that I had and which ones wouldn't interfere with like being difficult to assemble. For example, if I mounted the breadboard like somewhere else, this will make the wires which are in the ports on this side of the Raspberry Pi a lot harder to access. So that's why I ended up putting it on the front. Another thing to note is that there are a lot of diagonals in this thing as opposed to like vertical lids because of the limitations of 3D printing. Since I was using my own printer as well, I didn't really want to waste like support materials because every time you have to print another bit of support material, it has to purge the old support, like the old support material, and then because there's the filament hot end, it can only support one type of filament at a time because it's a single thread that goes through the hot end for the 3D printer. So it has to waste a bit of filament to change it from the old one to the new one. And that's why there's a lot of diagonals, because the 3D printer can print it's like slightly diagonal. I think this is a 30-degree angle, but it can't print completely vertical because there's nothing to print on. Yeah. So on to the challenges I had with working on this project, this milestone. So one of the main challenges I had with this was assembly, because as you can see, there are like 5 parts here, and they're all like really small and really tight fitting. Like if I were to open this up, it'll be completely crammed with wires. And I had to, in the end, I had to kind of like jam this case thing back onto the lid piece here, because there were the tension in the wires was kind of holding it up. And I had to insert another screw just kind of like haphazardly to the side to keep it from popping up like this, because there's only one screw here. Because I try to minimize the amount of screws that I put into my design, because I feel like too many screws makes it really difficult to assemble, and that would add to another challenge. And another challenge that I had with the assembly was getting the wires from the breadboard up in through the hole and into the pins on the Raspberry Pi. There are about 8 pins that have wires attached to them. There's 2 of them for the fan. There's 2 of them for the servos, and then the other 4 I think are for the ultrasonic sensor, because that one has 4 different wires attached to it. So the reason that this was challenging was because I had to thread all these wires through a hole in the middle of the lid. So that meant that as I was trying to get this wire and attach it to this bottom part in the Raspberry Pi, there was a big lid in the way that I had to kind of like get around and kind of like shove the little jumper wire port onto the pins. And this always ended up kind of like when I put in one of the pins, another one would come out, and it was always really challenging to do. Another design challenge was getting the servos out, because I actually forgot to design a part for the servos, for servo wires to come out. So I ended up, there used to be a part here that came up as a wall to kind of like block the like opening that the fan left in. So I just kind of like snapped that off to let the wires pour through. So that was kind of an interesting design decision, but it ended up working in the end. Another challenge I had with assembly was with the camera, because the camera is actually not attached to anything with any what's it called, screws, because the screw holes actually ended up being so tiny that the 3D printer couldn't physically print them, and the plastic ended up melting the small holes completely shut. So it's actually held up by this little bar, like the end of the wall for the wire cover on the electronics case. So I can actually, and it's also held in place by this rectangular thing, which rectangular hole, which holds the main box for the camera. There were also challenges that I had with printing, where the bed would occasionally warp and kind of like ruin the print. There's still warping on the prints here, like for example, because I printed this face down so that because it's kind of like it's hollow on the inside, so like I would have to print these overhangs, which I couldn't do. So I ended up having to print it on the lid like this, which ended up warping this side like pretty badly, but it wasn't in a way that affected the overall print because it interacted with the servo on the top side and not the bottom where the warping happens. And overall, I could deal with the warping on this part. But some of the parts I had printed before, like the electronic case, it had a really bad case of warping where the entire front side was warped upwards, which led to these ports being inaccessible. So I had to go and reprint that part. So overall, that's some of the challenges that I had with this milestone. And yeah, uh, if I had more time, I might look into maybe adding a third trash can, like for like a compost bin, because right now the trash can is handling both organic waste and like non-organic waste, like this plastic. So that would require me to get another AI model to train it on a more biodegradable uh types of material, like maybe like wood or something. I don't know if wood is compostable, but like yeah. And it would also require me to kind of reprogram the system so there would be 3 categories instead of 2. But yeah, if I had more time, that's something I would definitely do. So yeah, that's my third milestone.